So what I want to do today is cover just a little bit more on object output files and object input files, because I think they're pretty slick, pretty neat, but that's not the only reason. It's just a good way of thinking about doing file I/O. And if you were using a language that didn't support object output and object input, you could still simulate it just by writing functions that would read a line of data and then build your object in that fashion, right? Don't have to depend upon the classes that they give you. You can always roll your own. So without even hitting the PowerPoint, I want to go ahead and do one more object output, one more object input. Pardon me? Why did I launch Visual Studio? That'd be pretty awesome. No, why don't we try Netbeans instead? It's even better. You can do C development in Netbeans if you're crazy. If you want something that does both Java and C++, I'd recommend exploring Eclipse. I believe that Eclipse is a little bit more popular out in the industry than Netbeans even, so perhaps I should contemplate asking them to install Eclipse on these computers as well, but then it'd be something else that everybody'd have to install in a home. So the last thing we saw, we did object, we did a whole bunch of different things, and I was afraid that they blurred in each other's, How come Open Recent Project is grayed out? So the last thing we saw is that you could use an input stream to read in an object like that. Here we're reading in a string and a double, and we just read those two things, right? Rather than having to do any parsing and any conversion to that effect. And then you could have built an object based on those two things, right? You could construct, a new object. And since we're processing an entire file, you'd probably construct an array, or better yet, an array list of those items. And then our third example, which I hope I see, maybe I scrolled up all the way to the top. Maybe we didn't do it. Surely we did. Did we not do an array list? Yeah, read animal list, right? Where instead of reading the file in line by line, we just read the entire object into the animal list. There could have been thousands of elements in the array list, and it would have summoned them all back up. So I think this code is clear enough that you could go back and hit it anytime you wanted to see it. So I want to go back one step back, and instead of reading in the entire array list in one fell swoop, I just want to read in a series of elements and then add them to our own array list. So we're going to write two functions. Getting tired of animals. Employees. Also kind of tired of them, but too bad. And what's our parameter going to be? It's going to be an array list of type employee. Now we don't have a type employee yet, so we're going to do that pretty soon. And I'm going to call the employee list eList. All right, so we need an employee class, and we also need to add the import for array list. So up above public class, I'm going to add another class, class employee, and it's going to be our average ordinary one with a name and with a pay rate and with an hours worked per week. So string name, string pay rate, string hours, or hours a week. Hours is enough. And then let's write a method, a toString method for it. And for this employee class to work with object input stream and object output stream, we're going to have to tell it that it adheres to a specific interface called serializable. Fortunately, we don't even have to add anything to that, but implements serializable. Well, that didn't work. Oh, do we have to import serializable? Yes, we do. So add import for java.io.serializable. Better yet, let's just bring in object.io.star so we don't have to bring in anything else. So I'm changing that to import java.io.star. We're also going to need the Arraylist import. So add import for java.util.Arraylist. I'm going to cheat and make that java.util.star. Try to save myself from having to do any more with that. Okay, so let's do a toString. Let's do a constructor. Constructors are fun, right? Okay. Public employee string name. Why did I put all three of those as strings? You got me. Now we want to do something a little bit different. No, I think it's going to be okay. Since strings are immutable, it's okay to do what we're about to do with strings. Whenever you're passing in an object instead of a primitive value into a constructor, what you ought to do is clone that object. Why? Because you don't want two things that are referring to the same bit of data. Because if something goes and changes the original piece of data, it suddenly changed for your new object. But I don't think that we need to claim. We need to fix these. Well, why not? It won't take too much. So this dot name equals name dot clone. Is that going to work? Nah, of course not. All right, this dot name is equal to name. Not going to mess with it. This dot pay rate equals pay rate. This dot hours is equals hours. Our average ordinary every day. And let's make a toString. Public string toString. We're going to need to turn pay rate and hours into actual values so that we can process them. So double PR is equal to double dot parse double parentheses this dot pay rate. Double HR is equal to double capital D dot parse double this dot hours. And then double paycheck is equal to PR times HR. And if we were awesome, we'd put in time and half and all that kind of stuff, but there's no reason in making this overly complicated. Now let's just use string format to return a pretty string. So string S is equal to string.format. No name should be more than 20 characters long. That's a fallacious assumption. And then pay equals percent dot or dollar sign. Make it look all pretty. Percent dot to F. And then after the quote, we're going to print their name, this dot name, and then we're going to print out their paycheck. Then we need to return S because it's toString and it has to return something. Alrighty, that's our function. We could add, at override. Can we do that on the same line? That'd be neat. Hey, cool. All right. That's our only override. I'm going to build it, make sure that I don't have any egregious syntax errors. Finished building. Looks like it worked. Build successful. Is that true for y'all? Y'all need more typing time? Feel free to say so.
Almost there.
I'm going to condense it by putting the opening brace on the same line as the function definition, method header. All right. And of course, the things up here are name, pay rate, and hours. We could add getters and setters. Why not? Since it's so dang easy. Refactor. Just highlight your three variables. Refactor. Encapsulate fields. And then click refactor. And if we were really cool, we would be putting java.comments on all of our methods, and we haven't been doing that. Been slacking off for the constructor and for, well, we only added 2 of our own methods. All right, so you good to go?
Nope.
Alrighty, we have our employee class. We have a function called writeEmployees. We're going to write another function called readEmployees, which is going to return an array list of employees. So it has to return an array list. Public, static, read employees. Parentheses. Doesn't take anything. Ought to take a file name. Let's take a file name. String file name. Let's just create an array list and return it for now. We haven't filled in our stuff yet. So employees is equal to new array list. Angle braces, parentheses. And then on the next line, let's just return that. Oops, I forgot to give it a name. How about eList? Array list, angle braces, employees, eList is equal to new array list. And then return eList. I'm going to get annoyed at myself for always having to type in that capital L, but all right, I still got an error. What's going on here? Syntax error. Invalid method return type. Oh, I never declared it? I was sure I had. Okay, fine. Copy your return type from here, array list employees, and paste it there. And it's not called employees, is it? Our type, our class is just employee. May split declaration into a declaration and assignment. Yeah, we know that. What's this one? Exporting non-public type through public API. Well, that's very true. The employee class is not public. And since the employee class is not public, why in the world are we declaring this as public? But in real life, we would put the employee class in its own file, and it would be public, so I'm not going to concern myself with that. Okay, so down in main, let's create a few employees, at least 2. Employee E1 is equal to new employee. Joe Bob works 40 hours a week. I hope I don't have these reversed. At $12 an hour. On the other hand, maybe he works 12 hours a week. And I forgot I made everything strings for some reason. One reason that why all of this stuff may be strings is if you were reading this from a web form or from a GUI, because GUIs tend to return everything as a string, and then it's up to you to convert it. Then just copy that line, paste it, make E2, and just put some different information in there. His sister Sue Bob works there. She doesn't work as many hours, but she earns more money. Now create an array list. For that, you could just copy that line. And let's add those guys to it. elist.add E1, come on, elist.add E2. Now what I was talking about before about cloning, when we do an add, it just adds a reference to that array list. If you went back and you changed the values of E1 and E2, those values in the array list would also change, which is kind of a disturbing thought, right? You've been adding all this stuff to an array list and something's turning around and changing it, which is why the idea of cloning data comes about. You might want to write your own function, your own method that would take an employee, clone it before you put it in there. And what does clone mean? Create a new object and copy the elements one by one from the old object. You could implement it as a fancy constructor, or you could write a method called clone. Okay, so we have a function up here called write employees. So write employees, and I think I forgot to make it take a file name. imps.txt. I'm going to have to go modify that, comma, elist with a capital L. And then, although it's silly, let's just read in our employees with the same text, same reference. We ought to create a new one, but it's faster just to type it that way. elist is equal to read employees, quote, emps.txt. And if we don't get to the other things that I wanted to do today, the videos are out there. I'd recommend you study them. Threading is really cool and important, but we haven't been doing operating level stuff in Java. Okay, so I goofed on write employees. I need to come up here and make it accept a file name as well. So scroll back up to write employees and make it take a file name. String file name. System.out.println, quote, writing plus file name, just to make sure that this all works together before we go nuts trying to add more code. Let's do the same here. And we don't need to, it is returning something. But it's nice to have messages. System.out.println, reading plus file name. And I forgot to put a space there, so it's going to look pretty ugly on the writing message. Maybe I'll go add a space there. Right there. Alrighty, I'm going to run it and make sure that Elisa doesn't blow up with syntax errors. It ought to do something, not much. Writing and reading. Okay, it's lying. It hasn't written or read, but you know, we're good to go. You good? Alrighty. Okay, so write employees. We're going to do the same thing that we did last lecture. We're going to create a file. We're going to create an object output stream. and a file output stream. Let me cheat and remind myself of the order that you have to do that. Okay, that's what I thought. All right. So let's just enclose the whole thing in a try block. File equals new file, parentheses, file name, quote, right. Now let's create our file output stream. File output, capital F, capital O, stream equals new file output stream, passing in our file. Obviously I've goofed. Oh, unreported exception. Okay, we'll fix that later. Now for object output stream. Okay, I forgot to give this a variable name. I like just FOS for file output stream. You feel like giving it a more informative variable name? But you just saw me add that. Object output stream, OOS, is equal to new object output stream, passing in FOS as the argument to our constructor. And yeah, it's getting really picky about the fact that we're not catching all the required exceptions. We might want to add those catches right now. Do not do add a throws clause. That's just bucking the problem back up to the client code. Do add catch clause. Do another one, add catch clause. Just for now, delete those logger lines. We'll put some better error messages in there that doesn't use a logger class. Okay, cool. Need to check something. S dot. Okay, since we're writing, this is going to be pretty easy. We have an array list. We can just step through it. For, parentheses, employee E, colon, E list. For every employee in the E list, just write that baby out. OOS dot write object, parentheses, E. Now, if we wanted to be cool, we could have just done OOS.writeObject eList, and it would have dumped the entire list. Why am I doing it like this? Because hopefully we could make it so that it would append. And if you're appending by element, it's easy to read that back in. But if you're appending by array list, then you have to read in one array list, you have to add in another one, and then another one, and then concatenate them all. Don't feel like doing that. All right. If we had done, try with and opened the stuff up like that, then these would be self-closing. But they're not, so let's go ahead and close our files. FOS.close. We can close them in the reverse order. OOS.close and FOS.close. And honestly, they would get closed anyways as soon as they fell out of scope. All right, so we have two catches that we need to put error messages in here. System.out.println could not open plus file name. Let's add the fancy word error in front of it. Error, could not open file name. And then just copy that line and paste it into the IO exception. Just change the text a little bit. All right, system.out.println error, IO error writing file name. Kind of messes that drives the customer crazy because they have no idea what an IO error is. All right, I think we're sitting pretty. That's the end of our catch, and this is the end of our function, end method. Then we have another one. But why don't we just run it and make sure it works? But let's print out the absolute path to the file, just to be sweet. So, system.out.println. And where did I put this? I just need to put it somewhere underneath the line that says file equals new file. System.out.println opening space end quote plus file dot get absolute path. I still keep meaning to go and research the difference between absolute and canonical. But that way it'll print out a message saying where that file is, so that when we want to go and look for it, if we did, we'd know where it was. All right, gonna build it, gonna run it. All right, could not open emps.txt. Wonder why. This path looks pretty lame. It's got a /w there. Maybe I got the syntax for creating a new file wrong. I'm sure I did. I'm sure that I don't specify the right access there, unlike Python and C. So there we go. Take that out, and it's going to be a lot better behaved. You see where I had that comma W? That needs to go bye-bye. All right. So it told us, here's the complete path to it, right? So yay. Why did I? Okay, and then supposedly it closed it, although we don't have a message there. And then it invoked reading emps.txt. Working for y'all?
Yep.
Okay. So we're going to do the same thing here. We have our employee list here. We need another try catch. Got to do pretty much the same thing, except these are going to be input streams. So file, lowercase file, equals new, cap file. Let's print out what we're doing. System.out.println opening space end quote plus file dot get absolute path. Now let's create our two streams, file input stream and object input stream. File input stream accepts a file as its argument. It'll also just accept a file name. We did not have to create a file object, but I like having the file object so that you can do stuff like, get its path to it. Okay, so file input stream, FIS for file input stream, equals new file input stream, parentheses in parentheses, passing the file in, semicolon, and then object input stream, passing the FIS in. Object input stream, OIS equals new, object input stream, passing in our file input stream as its argument, FIS. Let's add our catches, just so that we get rid of all these errors. Guess we better add the catch right there. You're not going to do it for me? Unreported exception, add a catch clause, unreported exception, add a catch clause, delete our logger lines. And what's this one? No suitable constructor found because I didn't put the file name in. All right, that line's messed up. Pass in the file name string there. That makes that go away. All right, what's that fancy syntax for specifying two exceptions in the same catch? I forget if I ever did that. to spend much time looking for it if I can. It had a cute little offer over here to combine the catches. Not seeing them. Nah, I'm not seeing them. Not going to waste time. Okay, so one thing I noticed over in the file that I just looked at from last week that we're not seeing in this week is that it was offering to try with resources on some of these things. But okay, so we better print our error messages out. System.out, we could just go and copy them. System.out.println could not open plus file name. We could have done file.getAbsolutePath, right? But sometimes the user just wants a file name. We've already printed the path. And then system.out.println. Oh, I forgot to add my word error there. I like seeing that. Error dash could not open file name. And then on this one, error dash IO error reading space end quote plus file name. All right, now we never actually read it. We opened the file, but we never read it. So we're going to fix that. But still, let me check something. All right, I know how to do it in a primitive fashion, and I didn't want to do it in a primitive fashion, which is just reading to the end of the file. Reading to the end of object input stream with while loop. Well, it's a pretty silly way to do it. All right, we'll do it the primitive way, but it's an okay way. What we're going to do is we're just going to stick our reading code in another loop, and if it ever throws an EOF exception, then we know that we're done reading. Slightly primitive, but I didn't see another way to do it, so that's what we're going to go with. All right, so let's also put that in a try. Why? Because I just want to be able to close it. I don't want it to be treated as a fatal error like these are if we hit the end of the file. Okay, so let's read our line of data. We have an employee that we hope to get. Employee E is equal to, and when we read from an object input stream, we have to cast it to our type. So I'm going to do a cast. Employee E is equal to parentheses employee into parentheses OIS dot read object. And this one does have what I consider a fatal error. And I don't want that to be inside this loop. I actually want to catch it down here. So I'm going to go down here and catch that loop, catch that error. I don't like the way it defaults to putting the catch on the same, right? But anyways, catch, what was it, class not found? Exception. Let me cheat. Yeah, class not found exception. Okay. Class not found exception EX And I'm putting this parallel with our other established catches because this is a serious problem. Class not found means that the object output file was written in a different format than the object input file, meaning you probably changed your class between writing it and reading it. You can kind of get the idea that that's one of the drawbacks of object output streams and input streams is if you ever change your data format, if you ever change your record, you're in trouble. So we got to print out an error if that happens. Print line, error, incompatible data. Okay, now we need to add a catch for the end of file exception. So this does go under our try with our read object. So if I go to read object and I view the Java docs, I should see the exceptions listed that it throws. IO exception, class not found. Where's end of file exception? Tell you what. Fastest way to find it would, besides going to that page that I was just looking at, don't do this change. I'm just doing it experimentally. I want to see the error that happens when I run it without adding a catch for the end of file error. Nothing. Oh, because it's not in a while loop. I didn't put it in a while loop, really? Okay, while true, while parentheses true, into parentheses, curly brace, enclose our read object line in that. We do need that, so go ahead and add that. There we go. Error, IO error, reading emps.txt. But I want the more specific error, so I am going to come over here and look. The specific error that we want is EOF exception. Okay, so I'm going to restore my try and my catch. Try this business, and then while true, employee E is equal to that, catch EOF exception EX. And you're going to tell me that doesn't exist? No. I need to close my loop one more time, right? Because I have a try, and then a while block needs to be fully enclosed in it. And then I have a catch. And I'm just going to put a little message there. System.out.println done reading file, or into file reached. It would have been easier just to write it all out with one call, to write out the entire array list. Alrighty, I was hoping that we wouldn't have to handle IO exception because we had another try catch down here that would handle IO exception. But apparently it's wanting us to handle it right here and now. So if you're getting that error, do an add catch clause for that. And, well, didn't it just fluff that all up with a whole bunch of things? All of these things. Boy, howdy.
Is it because you have some,
Am I missing? Dadgummit. Okay, gonna punt. I'm gonna take the try out because it's already all in a try block. I'm gonna take this closing. When are you gonna start being correct? And I haven't closed my try block. Okay, this is turning into a disaster. Sorry, guys. I'm fixing it so that I can then show it to everybody. Make it look a little bit better. to file not found. Wait, file not found's okay. Now what do you complain about that these are in the wrong order? Can be replaced with multi-catch, sounds good to me. Undo it. Class not found has already been done. File not found has already been done. IO exception has already been done. Alrighty, if I hadn't goofed that, here's what it needs to look like. I really apologize. Okay, so here's what we really have. Top of the try block. File is equal to new file. Open the file. File input stream is equal to new file input stream. Object input stream is equal to new object input stream. FIS. While true, employee E is equal to employee OIS.read object, but we never added it to our E list. So then elist.add our employee. So we need to update that line right there. And what's going to happen is it's going to stay into the while loop until it finally throws an end of file. We don't even have to print anything for an end of file, right? Because that's to be expected. But I'm going to leave it in there. You know, we could just catch it because that's our way out, but just leave it in there. You know, what I mean is after we've proven it works, we could comment that out, but leave the exception in there. All right, and then we have several catches. Catch EOF, catch IO exception, catch class not found, and return EList. And it went ahead and added these calls to logger.getLogger, but I'm not going to fix those. We would replace those with our own error messages. All right, how badly have I messed everybody up? Then down here at the bottom, return EList.
I don't know what happened.
All right, guys, so looking at the classes work, for a lot of people, putting the try inside the try did actually work. So we had a try here, and we had a catch end of file exception, and then the rest of the catches stayed below, you know.
Did you unpause it?
So it worked. Yes, I did. I hope. Yes. So if that worked for you, and then you uncorrected it, and then you made all these changes afterwards, well, I hope you get it working now. Okay, so let's run it. Let's see if it works. And I forgot to add my file closes. Don't know where to add them, so I'm just going to be totally lazy and let the returning out of the method close them as they fall out of scope. That's shameful, but it's what I'm going to do. All righty. All righty, EOF reached. Now we just need to print out our data. We have no idea how many records we've just read in. We could put a counter. But let's go back down to main and add a little loop for printing out our EList. So for employee E colon EList, for every employee in it, just print out EList, system.out.println E. Print out E. And I need to make a Dropbox for anybody who's going to leave early, so let me go and do that. Well, I got to see if it works first. Here's my little for loop. This is in main, of course. And there we got our files. There we got our data. So we wrote this not as an array list. We just wrote it out as a series of employee records. And it took longer to do it that way. Am I coming up with a good reason why we did it that way? The only one that I came up with is so that we could append records to it rather than blast it and overwrite it each time. Because if we were appending employee records to it, that works great. Okay, Dropbox time. All right, guys, there's a Dropbox for it. By the way, do check your grades page. Make sure I haven't botched anything. Make sure that everything that you've got a grade on shows up in your grades. or that it doesn't look weird, like I gave you 100 and you see only 10 points there, or something dumb like that. And if you're looking at your grades, then you can see if there's something that you need to bump up if your grade's not what you want. Now again, this is not, etched in stone. Don't get mad if you see something strange. You still have time to work on this stuff, right? Our final is Thursday of next week. Work through Wednesday night and get all this stuff done. Okay. Also, if you want to skip the final, turn in a good project. You want to skip the project, turn in the final. You want to do both, and you get some extra credit. That would wipe out some missing homework or something like that. All right. So, if we had wanted to do it the way that I keep mentioning it, dumping out the entire array list at one time, here's what it would look like. Let's just copy the entire write employees function, paste it. So, write employees. I'm going to copy all that. Copy, 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 copy. Then I'm going to paste it and change its name. Write employees 2. Now this would create a mutually an incompatible file with the first function, so this is not really the best thing to do, and we're not going to test it out or anything like that. But inside write employees 2, instead of using a loop to dump all that stuff out, we would just do this, oos.write object, and then write out that stream, elist. Give me an error, or you're just highlighting that in red because that's what you feel like doing? Okay, I don't know why it's got that highlighted in red. Huh. Okay, and then if you wanted to modify read employees, I'm not going to even do it, but if you wanted to modify read employees the same way, you would replace this while true loop with a elist dot read object. Well, read list e is equal to array list, right? We'd have to cast it into the right format and all that. Same business, right? Array list of employees. That's our casting. Object input stream dot read object, like that. So you can see that's a little bit easier. Honestly, this isn't much more complicated now that we've gotten it done. I just got stymied by doing the nestled. Okay, so that's what I wanted to show y'all. A second example of reading and writing from object output streams, object input streams. I'm not actually super duper fond of doing this with files. Why? Because files are fairly permanent. And if you ever had to change that class, you'd have a serious problem. You'd have to write a conversion utility that would read in the data in the old format and then write out the data in the new format. But you can do the same thing for socket communication when you're opening a connection to another computer. And it's far easier, far more reasonable to say, you have to update your client because we've updated our server, right? It's not a permanent form of data that's going to be written out to backup disk, and then you expect to work forever. It's real-time communication, and it's reasonable to expect that as the server gets updated. It's just like games or whatever. You have to update your game because we've updated the server. Stuff like that. Alrighty. So, since we don't have time to look at the last thing, I strongly recommend you do them. I want to show you threads in Java. We don't have time to do them, but... Oh, I didn't... Yeah. I didn't put any output on it. Let me go grab one from prior semester. Phooey. And honestly, it's not that we got that far behind. Some of these lectures I recorded during finals week for those who were interested in last semester. If everybody wanted to skip the final and then come and do this, we could do that. Okay. Anyways. What are threads? You're probably used to the idea of a process. each application you launch is a process. If you come over and look at your task manager, or whatever it's called on your Mac or Linux, you'll get a list of applications and processes. You'll see a whole bunch more processes than you do applications. Why? Because a lot of these things are what are known as services. A service is an application that doesn't have a user interface, right? It just runs in the background. In Unix, Linux, they're called daemons or daemons, however you want to pronounce it. Chrome launches a different process for each window. A lot of browsers didn't do that. Instead, they launch a separate thread for each window. So what is a thread? What if your program, one application, one process, has to do multiple things? Like a graphical user interface application. If you don't write it as a multi-threaded application, then while it's doing something, you can't interact with it anymore. Like if you were doing a save as, and that save was taking a long time, the entire screen would freeze. Y'all have probably seen this, right? Where the application freezes, and if you drag the window around, it leaves, the entire, the window becomes white, and it leaves it. What's happened then is it's no longer handling events. The operating system is supposed to be sending events into your application, and your application is supposed to be able to handle them. But if you're doing single-threaded programming, then you have to handle them sequentially. If you're using multi-threaded programming, you can handle them. You get one, you start working on it, but then you can get the next one and start working on that one as well. So you can get several things going. And y'all have heard about multi-processing chips, right? Multi-processor chips. Multi-threaded applications are nice because they can divvy up the work between the different processes. So a thread is like a process that runs inside your application. It's a lightweight thing, and a process, has to have a whole bunch of stuff. It's got to allocate its own memory and stuff like that. A thread will use the memory that your application is already managing. I'll put that source code out there so that you don't have to watch the videotape just to ogle this. Alrighty. So, the way it works is you create a class. I'm not seeing, here we go. That extends, that inherits from the thread class that Java gives you. And you implement a run method. The run method is what the thread is supposed to be doing as soon as you launch it. In this case, it's just calling a method called doWork. This is kind of like a constructor. As soon as the thread is instantiated and then launched, it does the run method. The run method is called. So what is doWork going to do? With doWork, all it's going to do is print some messages. Right? That's pretty lame. But it's just going to keep printing messages until we're tired of printing messages. In this case, it's only going to print 3 messages. We could have made it print messages infinitely. So we had a constructor for our cool thread, which took a thread number and an application pointer. So when we wanted to launch cool thread, and we could make as many threads as we wanted to in our application, what you do, we created 3 threads. You create a thread like that, you use your constructor, you pass your application pointer in there so that it can call your own methods, so it can get access to your static methods, and we passed in just a counter number to give it some kind of little name. You don't have to write your own constructor for a thread, but we did so that we could pass into this reference so that we could get a hold of functions inside this class. And we passed in a int so that we could label our print messages with a number so that we would see what they would do. So you create your thread and you launch it. If you want to, you can interrupt a thread. Time to kill the application, time to bring it down. You issue interrupt commands on your threads like that. Otherwise, as soon as you've launched it, it's fire and forget. This application doesn't have to handle it anymore. So let's go back up to cool thread or down to cool thread. But you see that every time we called sleep, what does sleep do? It tells the thread to go to sleep for a certain number of milliseconds. Why do you do that? Well, your thread doesn't need to sit there wailing away on the processor without pause. You want to rest for a while to give the other applications, the other processes, the other threads a chance to work. Nowadays, with threaded processors and multi-processing systems, you might be able to get away without doing a sleep. But what this is saying is, okay, I've done some work. I'm going to chill for a little while, and I want the rest of the threads and the rest of the processes to do some work. But if the client ever sends an interrupt, yo, it's time to die, then we have to catch that. Here's another example of where you have to do a try-catch. Anytime you call the sleep method, you have to implement it in a try-catch because its sleep may be interrupted. What if you said, not 1 millisecond, you told it to sleep for 10 minutes? You don't want your application in some, nebulous state waiting 10 minutes for that thread to return. That is the idea behind threading. Strongly recommend you go ahead and you follow the video. I know everybody has lots of free time next week. Go ahead and watch it. And then there's another one over directory access. Directory access meaning that you open a directory rather than a file. And from the directory you get a list of directory entries. And those directory entries tell you whether something is a file, whether something is hidden, whether something can be opened, or whether it's locked, whether it's a directory. And so when you're listing files on screen of things that you want to open, you would only want to open or list the files, that were not directory entries. Because, when you got a folder open, you see both. You see both files and directories, right? And your application needs to be able to distinguish the two when you're trying to present a file list. So you get a call, you issue a call, it returns a list of directory entries, and then you can do things with those directory entries. Like what? You could open the file, right? You could delete the file. You could rename the file. That kind of stuff. You're interacting directly with the operating system. It's the operating system that handles calls to rename, right? Or to, delete and things like that. But your application can do that. Your application can go and make calls to the operating system in that fashion. And that is another one of the videos. Like I said, since D2L shuts down, you might just want to bookmark the playlist. I'll add those videos to the playlist so that you can find them later. Alrighty. I hate for this to be our last class. I'm going to miss y'all. If you haven't taken C#, you might want to take it. It's a really cool language, and I've known some people who took C# after taking advanced Java or simultaneously with it, who then decided that they like C# better. And it's an extraordinarily popular language in large companies because you can do easy server-side programming along with client-side programming. You can do server-side programming with Java as well. That's actually one of the primary things it was designed for. Alrighty. So what y'all gonna do? You've already turned in your project. You gonna do a project, or you gonna, oh, you said you're gonna do both.
Yeah.
Okay,
I
that's
wanted
cool.
to do both.
That's cool, that's cool.
I was debating about, because in Python I wrote the crypting one already.
Yeah,
The cipher, Caesar cipher one.
port it over.
Yeah, so I was thinking about porting it over, or I was gonna do the hangman one.
Okay.
So, because that's kind of like a fun little
Hangman's
game.
a fun little thought exercise. I wrote it real recently so that I could give somebody pseudocode for it, and I had a good time doing it, so I
Yeah.
recommend it. Yeah.
That's the one I did that wrecked my brain.
Yeah,
Hangman?
it's a thought exercise. It's
Just a
harder
way to
than it sounds like it's
get
gonna
it
be.
to display before you asterisk, as in, say your word was hangman, and you want to display the word in asterisks for them to guess on. You keep throwing letters at it, and if they guess it right, displaying only that letter,
Oh, okay.
and that was kinda tricky.
Yeah, yeah, I agree. It's oddly a lot easier to write in Python than it is in Java.
Yeah, it is. I think so.
Yeah, that one absolutely. So yeah, I'd like to see your cipher. I'd also like for you to do Hangman, so
Yeah.
one's cool. All right, so if you're gonna take the final, I'll see y'all next week, or you can take it online. You know, I'll put the Proctor U, or you can take it at the testing center, but otherwise,
You'll be opening class here?
yeah,
on Sunday?
yeah, yeah,
On Thursday? Or?
yes,
Okay.
yeah.
Yeah, I'll be in then.
Cool. Alrighty. So, when I see y'all in another class, until then.
Yeah, 'cause